Hello scientific people. Today we are going to derive an expression for velocity and kinetic energy of an electron in nth orbit of hydrogen-like atom, and we are also going to study its dependency on the principal quantum number n. So here we have an atom in which there is one orbit, hydrogen-like atom, and suppose its atomic number, mass number are given by following way: x, z, a. So z are the number of protons, which makes the charge of the nucleus as plus Ze. Here is an electron having charge minus E, and since the electron is performing circular motion, so it is experiencing a radially inward centripetal force, which is given by an expression mv square by r, mv square by r. Now this m is the mass of the object which is experiencing the centripetal force. So v is the speed of the electron, of course. So mv square by r, this centripetal force is being provided by the Coulombian force of attraction between the nucleus and the electron. So 1 by 4 pi epsilon 0 into Ze into E, so that is Ze square k q1 q2 upon r square. So q1 is Ze, q2 is E. We'll only take the magnitudes and divided by the square of distance between them. So it would be upon r square. So I can cancel one r from here, and another formula I have is the postulate of Niels Bohr, that is mvr, that is equal to nh upon 2 pi. So what am I going to do over here is I am going to shift these two mv down over here. So I will get nh upon 2 pi mv. Now this value of r I am going to substitute it over here. So mv square is equal to 1 by 4 pi epsilon 0 Ze square upon nh and upon 2 pi mv. So what's going to happen is, now mv square, that is equal to 1 by 4 pi epsilon 0 into Ze square upon nh, and this is going to go up 2 pi mv. mv, m, 1v from here gets cancelled, and 2 and pi, and this remains 2 over here. So now what do we have over here is, we have expression of velocity of an electron in a hydrogen-like atom whose atomic number is Z, that is given by 1 by 2 epsilon 0 h into E square multiplied by Z by n, a very important expression that we have derived, right? So from here we can say that the velocity of an electron for nth orbit of any atom whose atomic number is Z, for hydrogen-like atom, V is proportional to Z by n. And for a given atom, we can also say that V proportional to 1 by n, because for a given atom the Z value is constant. So for different orbits, the value of V would be different, and we can see that as n increases, V would decrease. So as you step on to higher and higher orbits, the speed of the electron would be decreasing, right guys? Okay, and in the same way, so if the speed decreases, then the kinetic energy definitely decreases. So let's talk about the expression of kinetic energy as well. So I'll have to make a small partition so that my work actually does not look untidy. So right, so let's talk about now the kinetic energy part. So kinetic energy is now very simple because we have derived the expression over here. So kinetic energy of an electron in the nth orbit, that is given by half into m into v square, right? So we know what is the formula of v, so we can plug it over here. So kinetic energy is half times mass of the electron times the square of the velocity, which we have derived over here. So it is E square Z upon 2 epsilon 0 hn, right? Okay, so kinetic energy is equal to half m e raised to 4, then it would be upon 4 epsilon 0 square h square into z square upon n square. So that means everything is constant. So kinetic energy is proportional to z square upon n square. Another important relationship. And for a given atom, I mean z is constant. This is for different atoms. So k is directly proportional to 1 over n square for a given atom, right? Okay, so guys, this is it, and let's try to actually find out what's the velocity of the hydrogen. For hydrogen, z is equal to 1, and I'm talking about the first orbit. So let's put the value of n as 1, and let's try to find out what is the velocity. So I'm going to use this equation, velocity of an electron in the first orbit. So E is 1.6 into 10 raised to minus 19 coulombs, and the whole square, multiplied by z is 1 upon 2 into 8.85 into 10 raised to minus 11 SI into this h is Planck's constant, 6.67 into 10 raised to minus 34 joules per second, or SI. Again n is 1. So guys, if you solve this, you will get approximately 0.2 into 10 raised to 6 meter per second. You can see that this is a huge velocity. So the electron moving in the orbits, their speed is of the order of 10 meter per second, 10 raised to 6 meter per second. Such a huge velocity, guys, right? But this is as per the Niels Bohr's model, and hopefully you like my explanation, and do subscribe to my channel for again the next part of the videos. Like, I'm going to talk about angular momentum, I'm going to talk about potential energy, I'm going to talk about torque, I'm going to talk about inertia, etc. related to these of the atoms, the hydrogen atoms. Thanks for watching the video.